Hey folks who missed class, I apologize. I thought I was recording the first 40 minutes of class and I was not. So sorry you missed all of the introduction about the app. And we are talking now about Google Colab. And specifically, we're looking at this GitHub repository with a repo about how to read data into Colab. And big thanks to Regina for reminding me. Okay, so making this big. So this URL, again, is what I got by right-clicking that same download tab and allows me to read in my Bike Trails dataset. Now, where is all of this stored? If you click on the left-hand side, it will actually show you the drive of your cloud computer. And it shows me that I've got about half of the 23 gigs available to me are being used. So it's clearly, it's a massive computer that is space that it's given me. And I go up one level and I can see actually the drive of the machine. All of my Colab stuff is saved here in content and then sample data. And that's where stuff is going to be saved. But right now, just in my local memory, I haven't saved it to the machine. Just in local memory, I'm reading in this Bike Trails data set. So, and all of this was actually supposed to be a little bit further down. So reading directly from a URL is one way to do this. Method 2 is to read a file that is already in Colab. Sorry. Method 2, use a file that's already in Colab. So as I showed you over here, it has a file called sample data. It comes with 5 default training data sets. And every Colab notebook will have these already available. The California Housing data set and the MNIST data set are 2 very popular machine learning data sets already divided into test and train for us, both of which I've used extensively. I don't actually know what Anscombe is. There's a JSON file, but it's in there as default, and a README to explain what the sample data is all about. So to use the sample data, all you have to do is call in your data frame. So California is going to be my data frame, and I do pd.read CSV, and the folder is sample data, and the file name is California Housing Dataset Train, and then cali.head, and there's the California dataset with housing, bedrooms, median house value, etc. Yes?
I'm not finding that CSV error.
If you click on this arrow, do you see the sample data folder? Is this showing up in your machine? And I'll do that again. So there's a small arrow here on the left. I click on it, and then I go into the sample data folder, and I have these available data sets. Are you seeing that on your screen?
Yeah.
Okay, great. So I would guess that it has something to do with maybe a possible spelling error in the extension. For example, did you include sample underscore data backslash?
I spelled California wrong.
Okay, phew. And what this demonstrates is we can navigate our cloud server just like we navigate in terminal on our own machine. So from pathlib import path and import OS. And now, just as we've done many times before, home is equal to path.current working directory. What is home? Home is \content. That's where everything is being run. And remember, if I right-click over here and I go up a little bit, this is my entire server library with all of the predefined software that's on it my stuff is being saved in the content folder. And if that's the case, then I can create, just as I've done before, data directory is equal to path.joinPath home sample data, and then I call data directory, and it's got that content / sample data, and I can do OS list dir data directory, and it lists all of those preloaded files. And I could even build out my file path and call it path.joinPath data dir / imnist test.csv, and then I could do df is equal to pd.read csv file path, and of course df.head, I meant to add that. And this is exactly the same as we've done things on our local machine, right? Except that we have to get used to the idea that we're not navigating our own machine, we're navigating whatever machine has been assigned to us out there in the cloud. Method 3, upload a file. Method 3, upload a file to Colab. Yes, go ahead.
Is this in the lessons?
No, but I did give you a link here in Slack to where I prepared a Jupyter notebook that has all of this information.
Okay.
So you do have access to it. It's just not in the repository. Uploading a file to Colab. Over here, you've got a upload function. So if I click on upload, it opens a dialog box, and I can choose something from my computer. Here's the abalone data set, which is basically data about sea snails, popular for machine learning classes. I choose open, it's all a manual, and it gives me a reminder, and this is really important. Uploaded files will get deleted when this runtime is recycled, which means as soon as you stop using Colab, it wipes that machine, and now it's available for some other user that's going to log into Google. So anything on upload won't be there tomorrow once I finish this session. So this is only for kind of temporary exploration, but it is good to know that the option is available. So now I choose that upload, and here it is. Now it's up here in Abalone. So it drops it into whatever folder I was in. I probably want it to be in content, because content is where my notebook is currently running. So I'm going to upload it again, but this time make sure that I'm selected in content. Come on. Upload Abalone. Okay, it's dropping it into some place that I didn't expect. All right, where are you? And how did I do this the other day? All right, os.list dir. Parent. Okay, for some reason that's all the way out here. But there's another way to get around this that I'll do in just a second. And then I could read in, so I would build a snail file path is equal to path.joinPath home.parent abalone.csv, and then snails df is equal to pd.read csv file path and snails df.head. And here's my snails data, which by the way doesn't have a header to it. because you have to read in the file names separately. But it's a whole bunch of information about snails.
Yeah,
No,
so
it's reading the old file path. Sorry, it's because it's not file path, it's a snail's file path, that's why. It's reading the old one. There it is. Okay, great. So we've got the sex of the snail, its length, its diameter, whether it was shucked, its shell weight, and rings, all that kind of cool things that everybody always wanted to know about snails. But there's another way of uploading stuff. This is method, here it is, from google.colab, import files, and then uploaded is equal to files.upload. When you run this cell, it will actually activate the GUI inside the notebook itself. So I can do the same thing as long as it's running. Choose the file. Let's do any other good CSVs in here. SQL queries, refugees. Fine, let's go back to the snails again. Now here's the American Community Server. That's always good. So I upload it, and notice I have to do this while the cell is running. Okay, maybe I saved it. That's too big. So once again, I run this cell, and while it's running, I'm going to go ahead and go back and choose abalone again because it's small. Open. Loads it up, and now in the next cell, now I can do df is equal to pd.read csv abalone and df.head. And I also get the snails. And the difference here is that with the manual upload, it dropped it in the highest level. With the in-cell upload, it dropped it inside of content, which is where the Jupyter Notebook itself is running. So it's easier for it to find.
how did you explain that?
See this cell here, cell 17?
Okay.
Opened this dialog box, and then I manually clicked on Choose Files. It reads my laptop and uploads the CSV file to the cloud.
I'm just saying that's the code that you need to do to activate that little GUI.
Yes, this you always have to use exactly this every time in order to activate this GUI. And I'm on here, method 4. Unzip a zip file. So this is similar to downloading from a URL, except that oftentimes data is saved as a zip, not as a CSV. This is especially true with Kaggle. So now if we were doing that on our local laptop, we would just download it, unzip it, and then read it from there. But you can't do that on your cloud machine because there's no terminal. You don't have access to terminal unless you use a really neat trick available in Colab, which is to use non-Python code inside the notebook. And I'll bet Jason is definitely familiar with, and others may be as well. If you put an exclamation mark at the beginning of your code, it stops being Python and it starts being Linux, so that you can use it for bash scripting as you would do in terminal. So for example, exclamation pwd gives my current working directory. Exclamation ls gives the contents of that directory, right? And other bash commands as well. And read data from a website is the bash command, and the exclamation, by the way, is referred to as bang. That's how you pronounce it. Bang, wget. And then for any website, resources.lendingclub.com /loanstats 2018 quarter 4.csv.zip. So if I were to throw this into my browser, .zip, it would download that file. And if I remove the zip, let's go all the way back out here to Lending Club. It's going to get a 404 error, I didn't expect that. The CSV by itself without the zip also can't be reached, but the zip can be. So this is the download from Lending Club. But anyway, that's neither here nor there. The point is that once you have the extension of the zip file, you read it in, run this, and it gets that and it saves that zip file to my machine. It's going to take a second. Back over here, we'll notice that, see how it's just added the zip file to my directory? Takes a second to read it down. And then once it's in, I can do bang unzip loan stats underscore 2018 quarter4.csv.zip. You have to wait till it's finished. By the way, another example of that, UCI, dataset, machine learning. Oh, what's the good one here? Sharing data set, data folder. There we go. Here's another one. Where that zip file is coming from. My lending tree example didn't work. But here's UCI, which is a common source of data sets. And it has, let me zoom in a little bit here, the data is downloadable as a zip file. If I click on this, it'll bring it down to my machine, right? But if I right-click on it and I copy the link address, that's what I'm looking for. And I could drop that into, similar to what I did here, code, bang, wget, paste, and it would download the bike share data set from UCI. So anyway, this is done. Now using the unzip command, I unzip that loan stats file. And now I can read in my data frame df is equal to pd.read CSV loan stats underscore 2018 q4.csv. df.head. It takes a second to read it in. And there it is. There's the data for the loan data set. And if I'd done the same thing over here with the bike data, bike share data, I get it. So much smaller data sets will read in faster. And I could use the same bang unzip to unzip that and then read it into pandas. And finally, as we've done in the past, you can save stuff. So it was a cali.tocsv, new cali file.csv, run that. And then if I go back over here under content, notice all these new files that didn't used to be there. I've got bike sharing data set, loan stats, abalone, new cali file. Let's try unzipping the bike share data. Bang, unzip. What was the name of it exactly? It was bike sharing data set, which I can even use autocomplete on. Bike sharing data set. Well, anyway, I'm getting a bit of a tangent. I think you guys see where I'm going with this and how these are 4 different ways of reading in the data. But the 2 that are going to be the most important are going to be knowing how to, well, I know which one I was missing, right? Directly from, sorry, one more. Method 5 directly from GitHub. This is probably the most common. So if you have data on GitHub, as I do, for example, under Plotly-tutorial, resources, Titanic, for example, on GitHub, if you find a CSV file and you click here on the raw link, so this is the Titanic data, right? Survived, class, sex, fare, where they embarked. If you click on the raw button, it will give you the original data in CSV format. So simply save your data on GitHub, go to raw, copy that URL, and then read that into Colab. And df or your Titanic is equal to pd.read CSV URL and Titanic.head. And nice, there we go. So we've got our data frame ready to go.
Can you slide out that link?
The link to Titanic? Yeah. Yes, definitely. And if that felt a little disjointed, again, all of this code is available in this notebook that I slacked out originally in a somewhat cleaner format. But of these different methods for reading in, I guess what was a kind of a learning curve for me, and I imagine might be for you as well, is that there's 5 different methods, but they're not really the same ones that we use when we're working locally. On my own laptop, most of the time, I download stuff and open it from somewhere on my drive. That's not going to be a good choice when working with Colab because your machine gets wiped every time you start a new session. So it's not used for long-term storage. A much better strategy is if it's not your data, read it directly from the URL that you got it from, or read it in by unzipping a zip file using the bang wget functionality. If it is your data, upload it to GitHub somehow, and then use that raw.github user content in order to basically provide yourself a link to your own cloud-hosted data in GitHub. And then every time you fire up your Colab, even though it's a completely new machine, it's reading in the source directly from your GitHub repo. Okay? Yes?
If it's not our data, would there be anything wrong with putting it on our GitHub so we know if that link ever changes, if the link, yeah.
Oh yeah, that's a smart question. So obviously that gets into that, that's a question about data ownership rather than Colab. But as a general rule of thumb, if you can get it easily on the internet without having to use any credentials of any kind, then it's sort of free game.
Check
Right.
for licenses. Probably not, right?
So the big discussion I've heard is that companies will really get you for web scraping their data, especially Craigslist. There's a famous lawsuit where Craigslist won a lawsuit that apartments, right? So back in the day, I don't think this is the case anymore, Craigslist was really popular for apartments. And people would write bots that would scrape all the rental information from Craigslist and then resell that on their own website. And Craigslist added a text under their data that said, if you scrape our data, you owe us money, something like $500 for every line you scrape. And they actually won that case. So it has really tampered down on people web scraping data. But I guess that's kind of a long-winded response to your question. I think if you can get it, it's available.
Most published research papers will provide the data sets that they use for use.
Yeah. Most people want their data to get used. All the federal agencies are bending over backwards to get people to use their data. And companies that have private data, they're bending over backwards to protect it, which means you probably can't get it anyway. All right. Well, anyway, that's Colab. Again, super cool. Definitely going to change the way I work. Highly recommend it because they're basically providing you a very powerful computer. What this is designed for is actually for training data sets with machine learning, which is why obviously their examples are all test and train data sets. And as you know from machine learning, the training component requires a lot of computing power. Colab is designed for that. So they're giving you a powerful machine right off the bat.
Pretty cool.
Yeah. All right, well, anyway, one thing it can't do is get behind General Assembly's firewall of their private GitHub repository. So for the remaining 30 minutes of class, we are going to go ahead and take a look at lesson 12. Oh, sorry, 13. Repositories, Python. So in the last class, we saw repository 11, which was data visualization with Matplotlib and, stop that, Seaborn. I'm skipping repo 12 because you guys have done a lot of work with Plotly now, every single class. And most of what's in here is actually going to feel like training wheels to you at this point. But I do want you to be aware that this information does exist. This is actually a 3-day course I designed for Deloitte, which teaches beginner programmers everything about Plotly from the ground up. So Plotly figures, basic dashboards, callbacks, how to use Pandas data frame, tabs, pages, and then a whole list of all the examples that I've built out in Heroku, though this is a little behind the curve. So this information is available to you if you'd like to dig into it, plus a lot of other links to where you can read and educate yourself more about Plotly. And it's there at your fingertips, but I do feel that you guys will actually be very familiar with everything that's in here already. So I am skipping lesson 12.
But can we get it? Because it's private still.
Well, yeah, but you have partnership in here. Try clicking on that. Here, I'll send it to you.
Oh. Well, I did, but it's still, it won't
Right.
let me fork it.
Click on this link.
Okay.
Right? Should be there. If it doesn't, I can definitely make it accessible to you. But I think it is. So anyway, the 30 minutes I've got left is lesson 13 about feature engineering. So this is some more advanced Pandas code about how to generate new columns from the columns you currently have. It's got a section on joining and merging, which is more of what I did on Tuesday. We did a lot of join, merge, concatenate stuff, and this is just more practice examples of that. But there are two other notebooks in here. One is that same California housing data set we just saw with Colab, and the other is a data set of beer ratings, and it shows how to create some variables. So I think I'm going to go ahead and go with the beer option for right now because it's shorter. Code. Beer ratings is what we'll be working on. This is the solution code, as usual. Emoji when beer ratings IPYNB. So feature engineering is an important art of knowing how to create new data from the data you currently have. If we didn't have feature engineering, we'd often be very limited to the data that's provided to us. So suppose, for example, you had, for every taxpayer in the country, you had their regular earnings, right? And then you had the percentage they pay in taxes. Neither of those two things by itself is especially helpful. But if you combine them, earnings by percentage paid in taxes, you can determine how much each person paid in taxes and create that third column. That's a very simple example of feature engineering, much of which we've done already. So here's going to be a little bit more advanced feature engineering. This is the solution code. I am going to start a new notebook, Python 3, if you want to do code along. This is going to be beer class notes. Okay, and this is going to be Pandas code. import pandas as PD, and I'm just following along the solution code here. I'm going to do beers is equal to pd.read csv path.join path path.current working directory dot parent comma data comma beers.csv and then beers.head. Oh, forgot to import path, of course. From path import path. And there's our data and our breweries and so on. We've got the brewery name, the name of the beer, the style, the ABV, the number of reviews, the average rating of the beer, and then the city and the state that it came from. So this is a Kaggle data set for an exercise of predicting the rating of the beer based on its properties, and you can join it with a second data set about breweries. If you merge it with information and ratings of the brewery, you can actually do a pretty good prediction of the rating of the individual beers. It's kind of cool. I also learned that the city that I'm from, South Bend, Indiana, actually has the worst rated craft brewery in the country, or at least as of the time of this data set. Four Horsemen Brewery closed like 2 years ago. But I didn't know that until I got into this data set. It's kind of interesting. All right, so we're going to do some quick EDA. So how many beer styles do we have? We've got beers, beer style, in unique will tell me that there are 98 different styles of beer, many of which are similar, right? And what are the most frequent of these? So I've got beers, beer style, value counts will list all of them from least to greatest. And then I just do a head.5, and I can see here the 5 most popular, they've all got the word American in them. And what's got the highest ABV? So I can beers.sort values by beer ABV, sort values, sorry. And it's actually starting with the lowest, right? So we've got some really weak beers here at the top. In order to get the heaviest beers, we do ascending is equal to false, and then just choose the top 5. And wow, we've got some really strong beers at the top of this list. Now let's get into actual feature engineering. Okay, so let's identify beers with double in their name. All right, we want to create a new column or predictor because obviously all of these, some of these are going to have the word double in them. It typically is going to indicate a stronger beer, such as double hopped or something. All right, so first, analyze a single cell, and you can do beers beer style, 0 in order to see kind of how that text is. And we see that the text that's contained might have the word double in it in that very first row. And you can also get this, by the way, in a different way by using beers.loc, beer style, comma 0, which is the column in the row. That's great. I'm not going to fuss with that right now. I should know my .loc code better than that. But let's write a function to identify that. Write a function to identify if double is in beer name. So define, and I'm going to call my function double trouble. And what I'm getting at here is once you want to do advanced feature engineering, in previous classes I've showed you some simple feature engineering tricks. But for more complicated stuff, you're going to want to start writing your own functions and then applying that to columns. So we're going to create a function that will identify whether or not a string has the word double in it. If double is in row, return trouble. Else, return no trouble. Right? So that's pretty simple. And then we apply that, double trouble, to, this was going to be example text, right? So now I copy that, paste it into my function, and example text gives me trouble. But if I do the very next row below it, example text is now American IPA, and run it again, no trouble, right? And I could have used this to identify any number of things. This is a pretty simple function. But here's the money line. Here it is. This is the power portion of it for pandas. I'm going to create a new column. Beer has double is the name of the column, is equal to beers dot beer style dot apply double trouble. So I run that, make sure my data frame is spelled correctly. And now when I call beers.head, I have a new column over on the side, has double, that indicates whether or not that word is in the name of the beer. And I could have done that for any number of things. For example, suppose I want to just identify all the IPAs in the data set, right? That'd be a quick flag for whether or not it's an IPA, whether or not it's a stout, or whether it's an ale versus a lager. Because one of the problems with beer style is it has a lot of information in it, but the information has to be mined. For example, if I just want to separate into ales versus lager, which is the highest level separation, I would have had to go through manually and flag every time the word ale appears versus lager. But I could just modify this function quickly in order to create, right, if ale is in beer name, right? So I'm going to call this one ale finder. And then if the word ale is in row, or better yet, ale is in row.lower to make sure that it doesn't have anything to do with upper or lowercase, return 1, else 0. Write that, and then we're going to go ahead and apply it. And I'm going to call this one is ale finder, and then beers.head. And over here, 00011. So now I can quickly find how many ales in the DF. And I simply do beers is ale. That value counts, and I know that I've got roughly half my data set is ales, and probably the other half is going to be, I don't know, well, they're not all lagers, but some of them will be, right? So these are pretty simple examples, but you can imagine how with a little more time, you could write some pretty sophisticated functions and start generating a whole ton of new data for your data frame for whatever fine-grained analysis you would like to do, especially if you're getting into some kind of prediction. Okay, the other one is generate dummy variables. Have we talked about dummies before in this class? A dummy variable is when you take a categorical variable and you convert it into zeros and ones. $747. So let's start by shrinking our data set. Let's shrink our data set just to make it a little bit more manageable. Beers, because I'm about to blow it up. I'm going to shrink it down and then I'm going to expand it massively. beers is just going to be equal to two things. It's going to be beer style, and then it's also going to be beer ABV. So only those two columns. And maybe I'll call this beers 2, just so I don't overwrite my data. Beers2.head. So now I've just got a small data set. Print beers2.shape. It's tall and it's skinny. Could I do a lot of prediction with this? Well, no, because it's text data, right? Unless I convert beer style into a set of dummies. Dummy variables convert categories into 0, 1 columns. Lots of binary zeros and ones. AKA 1 hot encoding is how this is also referred to. Dummification or 1 hot encoding is the same thing. It's taking categories and converting it into 0, 1 columns. Don't remember why I did that step. That seems useless. Okay, let's convert beer style into dummy columns. So beers, let's call this beer dummies, great name for data set, is going to be equal to pandas.getDummies. GetDummies is a function to convert a data set into binary columns. And it intakes the name of the data set, which is actually beers2. You have to specify which columns you want to convert, or otherwise it will convert every column, which we don't want. We just want the one column, which is beer style. And then beer dummies dot sample. Go ahead and run that. Oh, let's go ahead and sample 5 rows. And we see now that we've got a really, really, really wide data set. In fact, if we add in the shape, print beer dummies dot shape, it's got 99 different columns, which, not by coincidence, is the number of different beer styles. Remember, print beers beer style value counts. Put all of that into length. So 98, the 99th is the, forget what the extra one is for. Oh, beer ABV, that's why, because I didn't remove that. I remember I kept the ABV column. So there are 98 different styles of beer on the wall. And I've got 98 beer style columns in my new beer dummies data set. It's basically pivoted from rows to columns. And the difference is they're all now zeros and ones, mostly zeros. In fact, in this particular, so there's a 1, there we go. Here's beer style winter warmer, happens to be index number 1056, which if I go back to my original data frame, beers.loc, beers, beer style 1056 is a winter warmer, exactly. Let's see what the old one was.
Definitely creates some stemming.
Why would you do this?
Yeah.
Like, what's the purpose of this?
Yeah.
So I will tell you. So this actually kind of leads into the other class I teach, which is the machine learning data science class, where one would be using Python to make predictions about things. We have a data set that has, for every beer, its ABV, and then its style, right? And with this information, I can now predict the ABV of a beer based on its style. I can train an algorithm based on all these zeros and ones so that any new beer it gets, I can predict what is likely to be the ABV of that new beer. So it gives a lot of kind of predictive power. You can't do that directly off the you can't do that directly off the text itself, because text in and of itself doesn't have predictive power. But when I convert the text, binarize it into zeros and ones, then you can actually generate a mathematical formula for predicting what would likely be the ABV based on the series of zeros and ones. And Max, you've done the data science course, so you're familiar with that side of it, right? It's the other side of the coin. You probably saw that a lot with John Codier, right? Yeah. A couple more things about this while I'm at dummies is that we don't really want this prefix. That's the name of the original column, has been fixed now to every new column. So in order to get rid of that, you simply specify, by default, the prefix is whatever the old column name is. So now I just say no prefix at all, and the prefix separator is also blank, because right now it takes the old column name as the prefix, and then it adds a separator, which is an underscore. Run that, and now I've just got the straight up names. And that gives you an example of how you can just add the prefix and the prefix separator to be whatever you want. Seeing what to squeeze into the final 5 minutes here, because there's a whole other notebook that I could cherry pick a couple things from. Here we go. I'm just going to show you a little bit of taste of data science code that you can do with this. So, how would we use this? So I might do from. Scikit-learn is an entirely new library. Model selection, import, train test split from scikit-learn linear model. We would import a linear regression model, so there's line of best fit. You go ahead and run both those imports. And as a visualization tool, import matplotlib.py pyplot as plt, and as we've done before, matplotlib inline to display it in our Jupyter Notebook, and import Seaborn as SNS so that we can visualize things. And we're actually going to go ahead and predict those ABVs like I was talking about. So here's a line of code which I'm not going to talk a whole lot about except to say that I'm splitting my data into training and testing data using a function called trainTestSplit. 0.3, and I would need to also define x, of course. So x in this case would be Beers 3. So the thing that I want to predict is my x variable. Sorry, that's my y variable. And my x variable might be Beers 3 drop, the same thing. So I've split my data into the thing I want to predict and the things that I will predict it by. Remember that whenever you drop variables, you also always have to specify axis equal to 1 because we're dropping a column. Oh, it's beer dummies, that's why it wasn't Beers 3. Beer dummies and beer dummies, there we go. Okay, and then I build a linear regression model using that same linear regression data that I imported earlier, and I fit it to my training data. Oops. So I've built a linear regression model. Go ahead and make some predictions. My predictions would be to use my linear regression model to predict on my testing data. And now, did that actually work out? Well, let's take a look here. We can do Seaborn regplot. X is our predictions and y is going to be our true values. Okay, and there we go. And this actually shows, for what it's worth, that just based on the name of the beer alone, you can take a look at the true ABV of the beer and the predicted ABV of the beer, just on the name alone. And there's actually pretty close clustering of the two. Because I've trained it on a set of data that had certain names, so certain names are likely to be associated with a certain ABV. Then I run it on my testing data, I find that those names are actually typically associated with the same higher or lower ABV, where there's a fair amount of predictive power in there. So I'm sorry, that was a bit of a digression. I just wanted to see what I could squeeze into the last 5 minutes in order to answer that question, why would one want to do this? But knowing how to do one-hot encoding can be useful for just a whole slew of things. So let me go and stop there. Rain's coming. We all probably want to get home and do whatever we're going to do on Halloween night. But listen, thanks so much. I hope you guys have a great weekend. Reach out to me over the weekend on Slack if you are having any trouble with your final project, and I will see you on Tuesday, okay?